In this unit, 1.3a, we will be exploring elasticities. Elasticity measures the responsiveness of one variable to a change in another variable, and is one of the most widely applied concepts in microeconomics. In other words, elasticity measures how much one factor changes in response to a change in a different factor. For example, if there is a significant change in price, that may lead to a very small or very large change in quantity demanded, depending on whether demand is inelastic or elastic. So let's explore further as to what it means for demand to be either elastic or inelastic. For the business sector, elasticity informs the firm about the degree to which consumers will likely respond to raising or lowering prices. Elasticity enables producers to be aware of changes in the prices of other goods to expand their current market production. Governments also use elasticities to determine which goods to place taxes on and whether or not to raise or lower income tax, as raising or lowering income tax stimulates or reduces overall household spending on goods and services in the product market. While there are 4 types of elasticities, such as price elasticity of supply, cross-price, and income elasticities of demand, this unit will focus primarily on price elasticity of demand. Price elasticity of demand, or PED, is a measure of the responsiveness of the quantity demanded with respect to a change in the price of a good, as we demonstrated with the models earlier. PED answers the question of how much does the quantity demanded change when the price is changed. PED is a coefficient which can be calculated using the formula as shown, where the numerator is a percent change in quantity demanded of the product over the denominator, which is a percent change in the price of the product. So for PED calculations, you must be able to calculate percent change. So to calculate percent change, take note of the following formula, where new minus old over old times 100 will equal the percent change, whether it's between a change in price or a change in quantity demanded. So why don't you do a little practice on your own? Why don't you read the following scenario here and see if you can calculate a percent change in quantity demanded. To check your work, you can look for the answers here. In this part, I decided to go ahead and give you the price change. So moving on to the next slide, if you combine the percent change in quantity demanded over the percent change in price, you will get a PED, or price elasticity coefficient, of 1.5. Here's another very basic problem for you to practice with. And to check your work, here's the formula with those values plus the answer. We will go over this more in depth in class. Again, here is another problem for you to check your skills, and here's the solution to check your answer. Notice that every time the price elasticity of demand is a negative coefficient. This is due to the law of demand, as the demand curve is always downward sloping, or negative. However, in order to simplify matters, economists usually ignore the negative value that comes with the coefficient in order to simply express the coefficient in absolute value terms. If the price elasticity coefficient is less than 1, demand is said to be inelastic because the given price change causes a relatively small change in quantity demanded. This means buyers are not very responsive to changes in price over the given price range. So for example, when the price of a can of name brand hairspray is $2, quantity demanded is 1,000 cans over the course of a month. When the price of the name brand hairspray falls to $1.50, however, quantity demanded increases to 1,200 units in that same month. The absolute value of the price elasticity of demand coefficient of name brand hairspray is therefore 0.636. You may want to verify your answer just in case. The coefficient is less than 1, which means consumers were not very responsive to the price change, and that the demand for name brand hairspray is inelastic. If the price elasticity coefficient is greater than 1, demand is said to be elastic because the given price change causes a relatively large change in quantity demanded. This means buyers are relatively responsive to a change in price over the given price range. For example, suppose consumers decrease the amount of specialty breads they buy at the grocery store by 20% when the price of these breads increased by 10%. The 10% increase in price results in a 20% decrease in the quantity demanded. So 20% over 10% is equal to 2, indicating that the consumers are relatively responsive to a price change and that the demand for the specialty breads is therefore elastic. If the price elasticity coefficient is equal to 1, demand is said to be unit elastic because a given percentage change in price causes quantity demanded to change by the same percentage. This means buyers respond to a given percentage price change by changing quantity demanded by the same amount in percentage terms. For example, if the quantity demanded of an output increases by 10% when the price of the output decreases by 10%, then the percentage change in quantity demanded is equal to the percentage change in price. The price elasticity coefficient is equal to 1, and demand is said to be unit elastic. Demand is perfectly inelastic when buyers are completely unresponsive to price change, and the demand curve is drawn as a vertical line at a fixed quantity, as we will see soon. This means the quantity demanded does not change in response to a change in price. If demand is perfectly inelastic, then the elasticity of demand coefficient will equal 0. Price elasticity of demand is where the PED's value will be infinite, when 1% change in the price would result in an infinite change in quantity demanded. A perfectly elastic demand curve will appear to be perfectly horizontal. Again, demand is perfectly inelastic when buyers are completely unresponsive to a price change, and the demand curve is drawn as a vertical line at a fixed quantity, as shown. It might be helpful to notice that this demand curve looks something like the letter I, which is the first letter of the word inelastic. Use context clues. And to use an example, let's use insulin to understand the kind of demand curve that we're looking at. The demand for insulin is a good example, since insulin-dependent diabetics will continue to take the medically prescribed dosage of insulin even when the price changes. Realistically, demand curves are not expected to be perfectly inelastic as price continues to rise beyond some point, but it is conceivable that a demand curve could be perfectly inelastic over a limited price range. The vertical demand curve implies that consumers will continue to purchase the same amount, represented by Q in this case, regardless of the price of this product. For the consumers in this market, insulin is necessary, and there are no substitutes, so they will be likely to continue to purchase the same amount of insulin even if the price exponentially rises. When demand is perfectly inelastic, changes in supply will impact only equilibrium price because quantity demanded does not change. An increase in supply leads to a lower equilibrium price, but will have no impact on equilibrium quantity. A decrease in supply leads to a higher equilibrium price, but equilibrium quantity stays the same. This can be verified by sketching the changes in supply on the graph as shown. Another possibility is that the demand curve is a horizontal line, as shown. A horizontal demand curve is perfectly elastic. Notice that this diagram looks a little like the letter E, and the word elastic begins with the letter E. So it's easy to remember which is perfectly inelastic and which is perfectly elastic. When demand is perfectly elastic, consumers will buy any amount as long as the price is unchanged. In the model shown, demand is perfectly elastic at a price of $4. This may occur if there are perfect substitutes available for this product. If the firm raises the price even a little above $4, then the quantity of this product demanded drops to 0 because consumers will switch to the perfect substitutes available from other firms at $4. The perfectly elastic demand function plays an important role in the model of perfect competition, which is presented in a later chapter. In this model, product price is determined by market forces. Equilibrium price occurs where market supply and market demand intersect. A single firm is too small to alter market supply, so it cannot cause market price to change. The firm is a price taker. Since quantity demanded equals quantity supplied in market equilibrium, the firm is able to sell all the output it cares to produce at the going market price. Therefore, there is no reason for a perfectly competitive firm to offer a lower price when the market is in equilibrium. When demand is perfectly elastic, a shift in the supply curve will not change equilibrium price. An increase in supply will lead to an increase in equilibrium quantity, and a decrease in supply will lead to a decrease in equilibrium quantity. It is unlikely that a market demand curve for any product would be perfectly elastic, but this kind of function is useful when studying the demand for a single firm's predictions under the assumption of the firm operating in a perfectly competitive market structure. Most demand curves slope downward to the right, and the price elasticity of demand will vary along the demand curve, even if the slope of the curve is constant. This is because slope measures the vertical changes divided by the horizontal changes, but price elasticity of demand compares the horizontal changes relative to the vertical changes. The model shown is linear, but using the midpoint formula to calculate the price elasticity of demand coefficient over different price ranges shows that elasticity decreases when moving down along the curve. If price falls from $19 to $18, for example, quantity demanded increases from 1 to 2 units. The percentage change in quantity demanded is 1 over 1 times 100, which equals 100%. And the percentage change in price is negative 1 over 19 times 100, which is equal to negative 5% approximately. The price elasticity of demand coefficient for this price range is therefore negative 20, which is greater than 1 when considering absolute value. Demand is elastic in this price range, which is price greater than $5 on the graph. If price falls from $2 to $1, conversely, and quantity demanded increases from 18 units to 19 units, the price elasticity of demand coefficient is equal to 0.12, which is less than 1. Demand is inelastic, therefore, in this price range, which is a price less than $5 on the model. The midpoint of this demand curve is at a price of $10 and a quantity of 10. The price elasticity of demand coefficient approaches 1 as price gets closer to $10. Calculating elasticity for a very small price change to $10 would give a price elasticity of demand coefficient equal to 1. So demand is unit elastic at price equal to 1, at price equal to 10. We're gonna add a few more things. So this is just the first half of Unit 1.3a. So we're going to continue to Unit 1.3a Part 2 next.